Today, we're digging into a single research paper that puts forward a really out there theory about how our sun was born. It pretty much throws the story we all know out the window and suggests something way, way stranger. So let's get into it. The whole thing really starts with this one simple but massive puzzle. The sun is ancient, right? And we're told it's got billions of years left in the tank. But the author of this paper basically says, hold on a second. How can a finite tank of hydrogen fuel possibly last that long? It just doesn't add up. And that kind of problem needs a pretty radical answer. So, here's our game plan. First, we'll tackle that fuel problem. Then, we'll walk through the author's wild idea of our sun's journey from a tiny moon to a full-blown planet. After that, we'll look at how it actually caught fire, how its own planets are supposedly keeping it running, and finally, the wild chemical reaction that might just make it last forever. Okay, first stop, the sun's fuel problem. This is really the foundation for everything else, where the author starts poking holes in the story we all think we know. So on one side, you have the textbook answer, right? The Nebular Hypothesis. A huge cloud of gas and dust collapses on itself, heats up, and bam, you get a star with a limited gas tank. But the author, Cuixiang Zhong, looks at that and sees what they call a serious defect. They're arguing there's just no way a limited supply of hydrogen could keep the sun burning for over 10 billion years. For this to work, the sun has to have a way to refuel itself. All right, so if the sun didn't start from a collapsing cloud, then where did it come from? And this is where the theory really takes a turn. Let's look at its proposed journey, from a simple moon all the way to a planet. And here it is. This is the core idea. The author basically says, look, the sun orbits the center of our galaxy, so it must have started as a satellite, a moon, orbiting some other much older parent star that's long gone now. This just completely flips the script. The sun wasn't born a star, it grew into one. So how does this happen? Well, according to the paper, our sun, or proto-sun, starts out as a little moon. Over millions and millions of years, it's like a cosmic vacuum cleaner just sucking up dust and gas, getting bigger and bigger. All that mass creates intense internal heat, enough to melt its insides and form a core, a mantle, a crust. Just like Earth. And this just keeps going with more material, maybe even some collisions, until it's a monster gas giant the size of Jupiter. But, being a gas giant isn't the same as being a star. You're missing that spark. So let's get to the really dramatic part. How do you light the fuse on a planet and turn it into a sun? The key to the whole ignition process, according to this theory, is the polar vortex. Now, we're not talking about winter weather here. Imagine a whirlpool in the atmosphere, over the planet's poles, but on a scale that's just hard to even imagine. The author sees these as cosmic engines, what we now see as sunspots, that are actively pulling stuff in from space and funneling it deep inside. And inside this giant vortex, things get crazy. Gas and clouds get sucked down this massive spiral drain. The journey down creates just unbelievable pressure, so intense that it squeezes this material into massive ice crystals. Some are described as being bigger than our entire planet. As the vortex spins faster and faster, these gigantic crystals start smashing into each other, creating friction and sparking just colossal thunderstorms deep, deep inside the planet. And this, right here, is the author's aha moment. On the left, you've got the conditions scientists agree you need to kick off nuclear fusion. And on the right, that's what the author calculates you'd get inside one of those protosolar thunderstorms. The numbers line up. The theory basically says this whole vortex mechanism is a natural fusion starter. And that's it. That's the spark. One of these thunderstorms becomes the match that lights the fuse. It triggers the very first fusion reaction. And in an instant, that giant planet is no longer a planet. It's our sun. But starting a fire is one thing. Keeping it burning for billions of years is something else entirely. And this brings us to what might be the coolest part of the whole theory, the sun's planetary engine. This is the natural next question, isn't it? Okay, so you get one ignition at a pole. How does that turn the entire planet into a blazing ball of fire that stays lit? Well, according to the author, the sun gets a little help from its friends, or, its kids, the planets. The real MVP here is gravity. Just look at this table. You see Jupiter? Its gravitational pull on the sun is more than 30 times stronger than Mercury's. In this theory, that massive tug isn't just keeping Jupiter in orbit. It's actually managing the sun's entire power system. Here's how it's supposed to work. The sun's spin gets those first vortices, the sunspots, going at the poles. But as Jupiter makes its long journey around, its massive gravity yanks on those sunspots, pulling them down toward the equator. And the author argues that as it does this, Jupiter actually replicates them, spinning off new sunspots. Then the other planets jump in and help spread these new sunspots all over the sun's surface. The planets are basically a distribution network for the sun's refueling ports. And if you're looking for evidence, the author points right here. We all know the sun has this activity cycle that lasts about 11 years. Well, guess how long it takes Jupiter to orbit the sun? 11.86 years. In this theory, that is not a coincidence. It's cause and effect. Jupiter's orbit is literally driving the sunspot cycle. So the planets spread the refueling stations around. But what's the fuel? And how does it never, ever run out? This brings us to the grand finale of this idea, the eternal reaction. The big idea here is that the sun is doing more than just smashing hydrogen together. The author thinks it's a much more clever two-step process, a closed loop that both makes energy and recycles its own fuel. Okay, let's break this cycle down. Step 1 is fusion, just like we'd expect. It releases energy and a neutron. But here's the twist. That neutron then flies out and smacks into a lithium atom that the sunspot has also sucked in. This triggers fission. The lithium atom splits apart. And this is the magic step. When it splits, it creates helium, but it also creates a brand new hydrogen isotope. And that new hydrogen, it becomes the fuel for the next fusion reaction. The cycle just keeps repeating. And as the author puts it, this whole thing creates chain reactions, providing an endless stream of fuel for nuclear fusion. Suddenly, the fuel tank problem is gone. The sun isn't burning through its supply, it's constantly making more. So, at the end of the day, you're left with two totally different views of our sun. In the standard model, it's amazing, but it's mortal. It has a clock, and one day it will run out of gas. But in the theory we've just explored, it's an eternal engine, a self-sustaining machine that's kept alive by the very planets it created. So to sum up the author's whole idea, the sun's energy isn't just one thing. It's this perfect combination of the sun's own spin creating the engines, the gravity of things falling into them providing power, and this brilliant fusion-fission cycle that gives it endless fuel. And that's what I want to leave you with. This theory completely reframes how we look at everything out there. What if our solar system isn't just a bunch of rocks and gas balls passively circling a star? What if it's one single interconnected machine, where the planets aren't just along for the ride, they're actually helping to build and sustain their own sun? It's a pretty wild thought.